Hello, everybody. So, on the very first day, we talked about what is machine learning and the paradigm or uh, the mental model for machine learning is basically we'll be having three kind of things: data, and and then model, and then we'll be having learning or matrices. Learning or matrix, not matrix, matrix or whatever you want to. The results, comparing the results. Right? In the data, we have further bifurcation. That is, we have to extract, we have to transform. Before we run the model, we have to extract, we have to transform, we have to standardize or scale, we have to encode. These are the different things that we will be seeing that before building the model, we have to do these things. Okay. All right. Now, for this part, we have different tools. One of the tools is Pandas. Anybody who is already in the field and can throw some light on Pandas? What is Pandas? What are the advantages of it?
It is used for data, I would say feature engineering or the data ETL process, I would say. It's like a PySpark for a smaller data set.
Yeah. So it takes care of all the four things, okay? It takes care of all the four things. It can take care of the extraction, transform, scale, and code. It can take care of all the four things. It's basically a library which is built on top of NumPy. All right. So everything is vectorized. The data that we will be looking for or that we will be having in Pandas will be in the form of a table, which is called a data frame. We'll be having rows, and columns. The columns in Pandas are called series. Basically, these series are nothing but NumPy arrays. Make sense? So we'll be having vectorized operations possible. Series, NumPy array. Make sense? So Pandas is nothing but which is built on top of NumPy. And the very first question that comes into mind of any candidate is that we have SQL. Make sense? We have other ways. We have normal Python also for extracting the data. Then why do we need something like Pandas? Right? Or should I be using Pandas? And one very important thing Alok said that we might have missed is for small data sets. All right. We'll talk about that also. That what if I have very much larger data? That's why what should we do? All right. We'll talk about that. But can somebody compare Pandas to SQL? Why do I need Pandas?
Pandas are much faster in processing.
Perfect. Pandas are much faster. Why? Because vectorized.
Yes.
Remember, for the data model and learning, we have an engine called NumPy. And that engine is nothing but it takes care of the compute. A computer science engineer cannot go anywhere if it is taking so much of currently to process this much amount of data. We are using the GPUs and still, the frontier models sometimes struggle. So it's not only whether you can do the things, it's whether you can do the things very fast or not. So Pandas is super fast because it is series are NumPy arrays. It's built on top of the NumPy. It's vectorized. And we have already talked about in the vectorized operation, we have SIMDs, compiled code in memory. Those are the advantages. And one more advantage of Pandas is what?
Variety of data.
Variety of?
It can handle variety of data. Like SQL is only for the RDBMs, like relational.
Perfect.
Right?
Perfect. RDBMS. All right. It's just relational database. Pandas can handle variety of data. And one more advantage of Pandas is it's not only it can handle variety of data, but it can handle the transform encoding also. For example, for categorical variable, if we want to do one hot encoding, if I want to do label encoding, then Pandas will be able to handle it. SQL will be able to do basic transforms like multiplication, combining two columns. But one of the things that Alok was mentioning was that it will be able to handle the smaller data sets. If we want to make two things, if we want to make Pandas handle bigger data set, then what should we do?
We have to break the data set, otherwise use Spark.
We have to either break the data set or use Spark.
Spark.
She's absolutely correct. And if we have to do the things, then we can process the things like in batches.
Yeah.
And Pandas supports something called chunking. It can process the data in chunks. So it can handle fairly large data sets, fairly large. Makes sense? Fairly large data sets by the method of chunking. But still, if we have huge terabytes of data, in that scenario, we cannot bring everything in memory, right? In those scenarios, we have to go with the Spark, solutions like Spark, or these days, a new competitor of Pandas has come, which is called Polars. We can use those kind of tools. But for classical machine learning, Pandas is a great tool, and we will not be doing all the possible Pandas. We'll be just doing the Pandas which is required for ML. And today's lab is on Pandas. We'll come back to the NumPy part, which we left later on. We'll surely complete that also. But today we'll be completing the lab belonging to Pandas. And we'll be exploring what are the useful aspects of Pandas for machine learning and what are the pitfalls, more than how to use Pandas for which situations we are going to use. We are going to know about what can be the possible breaking points if we are using Pandas. We have already understood how we are going to, what's the table, and if we have to show the table in form of the Pandas, then we can show it like this. We can initiate the data frame like this. All right. Pandas.dataframe, we'll import the pandas. Pandas.dataframe. This is the series name, which is in the form of a key of a dictionary, and then the values of it. All right. Country, revenue. For example, if I have to show the table, it will look like this on the whiteboard. That is user ID. User ID. All right. 101, 102, 103, 104, and country is another series. That is India, US, India, and Canada. And revenue is $5, $6, $7, $10. All right, so on and so forth. This is the way that we can show the pandas. The columns are called series, and we have data types. We have data types also. Data types are pretty similar to int64, float64. Basically, since it is built on top of pandas, the data types are also, it is built on top of NumPy, sorry. The data types are also inherited from how we are doing the data types in NumPy. All right. And data types is going to give me all the data types of the columns that we have. All right. So before doing anything, before going any and building any models, firstly, the interview tip is always check df.datatypes and df.shape. And third thing that we can do is df.head. All right. So df.head, df.datatypes, dtypes, and df.shape. Just like most of the things that we were doing in NumPy also. This is a new that if we have a very large number of rows, then I just want to see the very first 5 rows. Yes, hello, go ahead. What's your question?
All right, I don't have any questions.
Okay.
Maybe some outside noise.
Okay. Got it. All right. So for today, we will be exploring the lab, and let's make the initial data frame. We have two kind of data frames. We have two kind of tables. One is the user table. We already have the random number generator, which is seeding from 0. Remember, random number generator, if it seeds from a particular number, what's the advantage of that? Anybody? Why do we seed from a particular number?
Because same random number are going to generate at each
Yep.
time.
With each, whenever we are running our model or whenever we are exploring our data, it is the same set of random numbers which will be generating if we are seeding from the same place. And I wanted to focus on this x n minus 1 and plus c mod of m. How it is working under those, just a glimpse of it. All right. Nth number, the next number will be generated from n minus 1 if we are giving the seed as 0. I will be having a, some value of a, the earlier number plus c and mod of n. And based upon the type of the algorithm that we will be using, the a, c, and mod m will be decided. So if we are seeding from 0, always the next number which will be generated will be same number, then the next, then the next, then the next, then the next. And this is the way the default seed is making sure that all the numbers which will be produced will be same every time. All right. Now we'll go to some of the other things of Pandas. One is log and iloc. And let's use this table for that. Then we'll go to the lab and to look at the other table also. If I want to find what is the country of this cell, how can we do it? And let's call this users table. Then what are the ways that we can do the things? How do we get the value over here?
So we have to
Index.
Yep, indexing, right? So the question is, how do we do the indexing? How do we go to that particular index?
data frame country 0, 1, 2.
Users. Then what?
The series and the index.
Series and index, country. And indexes 0, 1, 2. Okay. Index 2. This is one of the ways. You can think it like this. That is index 1. But you can do that. All right. But we do not do it like this. We do it using log and iloc. We'll see the difference between log and iloc. But the basic idea is we do users dot log country index 2. Like that. Makes sense? Round brackets.
What is the usage of using log? Why do we want to use it?
Yeah, why not do this? Why do this? Anybody? Can anybody imagine?
Change the value on runtime.
No. Yes, Omkar?
we might not know the index of the column, so we can use the label name.
Okay, then this is fine, right?
Oh.
This is fine, right? Then why to use lock? Niharika has a very valid question. Why
A
do you use
lot
lock?
of times when we do data manipulations, like we might take out chunks or do slicing, right? So indexing will not be constant always.
Why will not be constant? Good.
Let's say like if I apply some filter, right, salary greater than something XYZ, right? So the indexing doesn't change unless you manually reset the index.
Let's go back to this. Pandas is a library which is built on top of what?
NumPy.
NumPy.
Okay. What is this in NumPy?
Fancy index.
Fancy index.
Oh yeah.
Fancy
Oh, it
index.
creates a copy.
Make sense? It makes a copy. This is what? Basic index. Make sense? The lock and the iloc are basic indexing. And this leads to the very first bug in Pandas. That if you manipulate something, then it would have, with the fancy indexing, it would have created a copy. And you keep wondering that I changed it, but now it is not behaving the way it is. Make sense? The lock and the iloc are the tools for basic indexing. Hence, we will always be using lock and iloc. We will not be using the fancy indexing. But what is the difference between the lock and the iloc? The difference between the lock and the iloc is iloc uses integers. So if I have to do the second index over here, then with the iloc, I will be representing index 1, 2. Basic indexing, but with integers. And we'll see. And with lock, I will be using the feature name. And most of the time, we'll not be using iloc, we'll be using lock. Why? Because we'll be having the feature names. Make sense? So the basic difference between lock and iloc is selecting and filtering is lock, and this is one of the fan gotchas. The lock is inclusive of both the ends. iloc is exclusive of on the ends. Just like substring, iloc is exclusive. For example, if you are mentioning the slice like up to 2, lock will give me up to 2, but iloc will give me before 2. Make sense? So lock inclusive of the end, iloc exclusive of the end. And the second difference that we have is the iloc is integer based and lock is label based. And that is part of your theory also, which is written right here. Make sense? Lock is label based and iloc is integer based. And lock, this will be asked. In fact, that where can you use lock and where you can use iloc. All right. If you're exploring, if you're getting your data at the data layer, if you're using the Panda. Make sense? So this
So
is
in this case, iloc of 1, 2 will take us to first row and second column, right? Zeroth row and first column.
Yes. This is fine. For iloc and lock, this is fine. This will give you the same consistent result. But in slicing, the lock and the iloc will be behaving differently. Make sense?
Oh, that is only for slicing, the n-1.
So for example, over here, if I have iloc, then 0 to 2 will be giving me 0, 1 only. Make sense? And 1 to end. Make sense? That is the basic difference between lock and iloc. All right. Now, the next step that we will be exploring is we will be going to our data. We have the user's data frame, and then we'll be making one more table that is called events table, in which these are the users and they are doing online shopping somewhere on Amazon. And they will be having different events. What can be the different events that a user can have? Different events are like view, add to cart, make a purchase, are different kind of events. If we look at the user behavior, and this is one of the skills that we'll be learning in these classes, is that we will be making our own synthetic data. If we are making your own synthetic data, it is valuable in two scenarios. What if you do not have the access to the real world data? And real world data is costly to extract, not extract, to collect. The real world data is costly to collect. All right. And as a machine learning engineer, whenever you find yourself saying, oh, I will get more data, all right, then that is not an easy or a very cheap decision. It is a sometimes very costly decision. So
Costly in terms of
money,
cost.
in terms of money, because you have to collect the data. You have to either have a digital platform for that, or you have to physically go and collect the data, right? That is a costly affair, not in terms of time or compute, but collecting it from the users. You need to have time. You need to have the distribution to collect that data. All right. So advantage of synthetic data is, one, you can create from some signal, you can create more data so that you can include it in your analysis. The other part is, once you're developing the synthetic data, then you will understand the nitty-gritties or the under the hood details of the data. Make sense? So if we have view, add to cart, purchase, the probability of view, probably 70% of the times, people will be viewing the items, and only 20% of the timings they'll be adding to the cart, and 1% of the times they'll be making a purchase. All right. These are the valid assumptions that you can make. We'll make this 0.7, 0.2, 0.1. All right. So initially, when we are making the data frame, we have already made the user's data frame with the dictionary in which the series names are the keys, and the series is 1, 2, 3, 4, the user IDs, country, the sign up timestamp. The sign up timestamp, we are using a date time object for that. All right. That at which time the user has signed up. All right. On this date, January 1, 2025, January 3, January 4, January 10, so on and so forth. And for the second table, the events table, we have three different kind of events. We have mentioned their probabilities also. With the random number generator, we can choose between these three events. The probability of them happening is 0.7, 0.2, 0.1. We are making a size, a user ID, we are making a size 30. The events table is 30 rows. We are using the replace rule. It means if we have used from the random number generator, we have made a choice from the user IDs, that is 4 user IDs. We are going to have 30. If we are going to have 30, the existing number of users is 4 only. That's why replace is equal to true, that if I have chosen 103 from this list, I'm going to replace it with 103 again, so that it can be chosen again. Why? Because one user can have multiple events, right? 103 can have view event also, another view event, another purchase event. That's why if we want to make 4 from 4 users, if I want to make 30 events, then obviously I'll have to make it replace is equal to true. All right. So user IDs we are getting from these users for making our data frame. Remember, I'm not doing one by one by one. This is a very smart way of doing things. That we are able to create a data table of 30 rows with these instructions only. User IDs, then event timestamp, again a date time. Then we are taking it from the January 1st, the date, plus we are adding a time delta, because every event will not be happening at the same time. Now. The event timestamps will be different. And we are taking a delta of 20 days. These are the minutes. 0 is number of days. All right. Sorry, number of hours. We are keeping it 0, but we are playing with the minutes. Minutes, how many minutes are there in 20 days? 20 into 24 into 60. Make sense? 24 hours and 60 minutes. And size is again equal to 30. So basically with this line, event timestamp, what we are trying to do is January 1st plus a randomly chosen delta of how many minutes? Among these minutes, among this range from 0 is not the hours, 0 is the range, 0 to 20 into 24 into 60. Between this range, choose a random delta. That will be the stamp of that will be added to the earlier day, that is January 1st, 2025. That will give me the timestamp of my event. All right. So this is what we are doing in this row right here. That is basically we are making an event timestamp by ourselves. And then the size has to be 30, again, because we have the 30 rows in the data frame. Then the event will be one of these 3 events. We have already mentioned the probability. We'll be making a size 30, replace true again. That if a event has happened, view can happen many of the times, right? Then what we are doing is choice of the amount. So we are having, in the events table, we have 4 series. One is user ID. User ID. Event timestamp. Here also. Sign up timestamp. Event timestamp. Next one is the type of event. Let's have the type of event right here. Event timestamp. And the last one is amount. All right. The amount that we are choosing is between the random amounts of a list, that is 0, 0, 19.99, 99.99, and replace is equal to true. If we have used any one of the items from this, we have to replace it so that we can use it again. All right. So now if we see the head of the users table and events table, let's see. It should be giving us the user ID, country, and sign up timestamp, user ID, event timestamp, event, and amount. We are doing a line 22. Just read this line and try to figure out for 1 second in your mind, what is it doing and why is it doing this? Apparently, we have already talked about location. Lock. Makes sense? That it is doing the basic indexing. That's fine. So this is the first part of the basic indexing. This is the second part of the basic indexing. That's fine. But what is it trying to do and why is it necessary?
Corresponding to where the event is not purchased, it's setting the amount equal to 0.
Perfect. What Suhas is saying, wherever the event is not purchased, so a mask. We mounted a mask. Makes sense? That mask gave us wherever the event is not purchased, we are making the amount is equal to 0. Why? Because if I am randomly choosing between them, it may be possible that for the view, I would have chosen 49.99. There is no amount associated with view, right? Add to cart, there should not be any amount associated with that. Only with the purchase, there should be amount which will be associated. This is what that line is doing. Make sense? And for filtering, we are using the mask, which we have already learned in NumPy. Does it make sense? This will give me an array of true and falses, which we are mounting on the events data frame, which will give me the indices. And for the amount, I will be making the amount is equal to 0. Cool. This is what the first part is doing. Now we go to we are already done with lock, iloc. Okay. Now we'll go to the filtering. Remember, in normal languages, how do we filter? We go one by one. For example, if I have to filter India, that what are the entries which are belonging to India? One of the brute force way of doing this is, all right, whatever, 2025, 0101. One of the brute force ways, go over each and every row, check where the country is equal to India. That is what we were doing. What are we doing in the NumPy based solutions to do the filtering? We don't do the for loop.
Mask.
We do masking. Right? We do Boolean masking. So if I have to check whether the country is India, I will go to events data frame or users data frame, sorry, users data frame. I'll go to the country and I will do the country is equal to India. All right. This will create a Boolean mask. Once this Boolean mask is created, we can mount this mask on the data frame. And that will give me just the rows which are belonging to India. This one and this one. Make sense? That's the way that we filter. And why do we filter it like this? Why don't we do a follow?
Vectorized.
It's vectorized. Makes sense? It is vectorized. That's why we are doing it like this. Makes sense? So now the very first task that we have to do in our lab is that we have to, let's do this. Let's have 0.65 over here, probability 0.25 over here, and 0.15 over here. I'm doing it because I want to have a little bit more number of, for example, if it was earlier one, if I ran it, if I ran the whole events table, among the 30 rows, I already had one purchase, I guess. Only one purchase right here. No other purchase. I want to have more than one purchase. That's why I'm making it 0.65, 0.25 over here, and 0.15 over here. The total probability should be 1. Make sense? Did I make a mistake somewhere?
It's
Probabilities do
one,
not.
right?
Yeah. So
line 20 I think maybe
0.60.
Yeah.
All right. If I do this, then it will be fine. Okay. So now I will be having significant number of purchases. I will be having more than one purchase. All right. So now, if I let me just add also. Okay. Although not required. So I'll have more number of purchases. While we are doing it, they say the filter to purchases only. Just give us the rows which are belonging to the purchases only. And how can we do it? Firstly, let's have a mask. All right. In which, for the mask, I will be having in the events table, if the event column is equal to purchase. All right. If I print mask, it should be giving us a 30 rows, true and falses. Make sense? The purchase happened over here, the purchase happened over here, 7, 8, so and so forth. Now we'll be mounting this mask on the events data frame. This was mask. All right. Don't get confused because this is essentially doing this. So mask, if I mount the mask on it, then it should be giving us the purchases. And to that purchases, we have to include an event day. All right. Let's just print the purchases right now. And then we'll be proceeding and adding a table, adding a column, because that may be a requirement that we have to add a column in our data frame. All right. So now we will be having the 4 entries, 4 rows, which are belonging to the purchase. Now, if we have to add another column, another series in the data frame, what should I do? What does the event day? All right, because this event timestamp is the day as well as the timestamp, right? It may be possible that we have to get the day. That which day? In order to do that, what we can do is the purchases data frame that we have, and then from which column we can get it? Event timestamp dot date dot flow to a particular date. These are some of the common things that we'll be requiring in machine learning. All right. Now, if I print purchases, it will be having one more column, that is the event date towards the end. Right. Okay. All right. And it passes all the test cases that we have. So basic filtering, adding a column. Yes, Lohit, go ahead. What's your question?
Just curious, like, will this new column will be added on the same address?
Let's see. If it is, he's asking whether the events will be. All right. So events table remains same. Makes sense? It gets added to the purchases data framework.
Okay.
All right.
Okay.
Because we are making a mask on the events table, a Boolean mask. That's it. All right. Then we are mounting that mask on the events, and that creates a new copy in the case of Pandas. Ideally, what should I be doing is this. Make sense? That is, I should be doing purchases. Ideally, I should be doing is events. That's a great question. All right. Events.copy. In fact, going forward, in order to make sure that we are not mutating the initial data frame only, we'll be doing purchases.copy. For example, I want to show you. Yeah, events.copy. Make sense? So going forward, so that we are not mutating the same data frame, I will be making this intentionally. Make sense, Lohit? That's a good question. All right, now let's go to the next task. Yep.
If we don't do events.copy, then if
It
we,
may-
let's say, because
It may mutate the initial one. All right.
but I think it will only mutate the initial one if we use the same, if we use events only, right? If we have purchases, then it will be different. No? It's a
But
separate data frame.
it is by reference now. We are mounting on the same A. It's by reference, right? It's an object, right? It should be by
right,
reference.
true.
Yeah, it's by
So
object.
will it mutate events in this case?
Right now it doesn't. All right. But we are not sure. And that's what when I was talking about Pandas, all right, it gave us an answer. It may or may not. All right. It depends upon some of the things. For example, this is the environment that I am working with. It's like it literally is a Jupyter notebook. All right. If you are working in a different environment, it may or may not. Make sense, Suhas? Yes, Niharika, go ahead.
Another question. So what is D here in line number 4? DT dot
It's day.
floor D.
Day. It's day. All right. If you have to mutate it if you have to floor it to the month, then this floor month doesn't work in the new Pandas. All right. If you want to mutate it to the month, then it gives us an error. All right. Then there is a separate function for that. All right. I think what is the function to the, if I want to mutate it to the month, floor to the month and Pandas. Then it is date dot to timestamp to M. Make sense? Or date to period. M. In that scenario, the floor will not work. Floor works only with the date. Make sense, Niharika? Now let's go to the next step that we are going to do is the GroupBy. That we have to do the GroupBy. For example, if we have multiple events over here in the events table, for example, 30 kind of events, and we want to see user ID is 101, 102, 103, 101, 103 again, and event is view, purchase, view, purchase. All right. Event timestamp is something. What we want is we want to see for a particular user ID, how many events are there? Number of events. All right. So in that scenario, what are we going to do? We are going to do GroupBy. All right. So how do we do the GroupBy over here? Events dot GroupBy. GroupBy on which column?
User ID.
User ID.
Right.
All right. User ID. And how do I get the sum of the events over here? So next step.
Aggregate.
Sorry.
Dot sum.
All right. Firstly, the user ID is GroupBy, and then dot on what column?
Sum.
Event column. Firstly, specify the column, event column, and then we can take the count or the size. Make sense? Size or the count. will give me the basically user ID 101 and number of events is equal to 2 over here, 103, 2, and 102, 1. Make sense? This is the basic way of grouping by when we have a grouping by for one element. Somebody mentioned aggregate. We can use aggregate also. And aggregate will be will be handy when we are doing the different operations for multiple columns. Make sense? I need the multiple columns like number of purchases, for example, number of purchases, number of events, and total revenue also. All right. So firstly, we'll just see the group by for one column only. Then we'll graduate to the aggregate function where we have multiple columns. We can do the aggregate for one column also. All right. But the basic syntax for the one column is like this. Make sense? So let's try to do the group by for just the number of events first. If we want to do print the events table, sorry, not the users table, events table, and group by on what? Dot group by on which column? Is event, sorry, not event, user ID. Group them by user ID dot, not dot, event, and we can take the size of them. All right, let's just try to print that, and we'll be having the user ID 101 has 6 events. 4, well, we can use the count also. All right, same thing. If we use the sum, what will happen? Why does it give us sum like this? Because this is not a integer base column. It is categorical column. Make sense? That's why the count and the size will work. The sum will not work. Make sense? All right. Now, in the user features, we want to make a different table which has 3 columns. Number of events, count of events for each and every user. Not only that, number of purchases. How many purchases he did. All right. And what is the total revenue that we got from? Because different purchases will be having different amounts, right? We want to sum them up. So my users features table has to have 3 things: number of events, number of purchases, and total revenue. In order to do that, firstly, what we have to do is we have to make sure if we have to do only one event, I could have taken the size over here. But every event, that will give me the number of events. That's fine. But if I want to make sure that whether this event, it's a view, it's a purchase, it's a view, it's a purchase, whether that event is purchase or not, what should we do in that scenario?
And mask and filter.
Mask and filter.
Yeah.
So basically making another table, right?
Another mask amount greater than 0.
Another table. We'll have to make another table. Makes sense? Or what we can do is we can add a column over here, is purchase. Basically, whether it is a purchase or not. Remember, we have to count the number of purchases also. And I don't want to make a filter for each and every user. Remember, it has to be grouped according to the user. So what we are going to do is we are going to make an is purchase function, is purchase column in the table. All right, like this. All right. So now, firstly, if you don't want to work with the same data frame, you can make a copy. Or I'll just make an events to events.copy. And then to the events to data frame, I'll be adding is purchase function, whether there is a purchase or not. And how do I make sure? What will this is purchase function contain? Whether there was a purchase or not. And how do we implement that? By having a mask that on the events too, I will be having for the event if the event is equal to a purchase. All right. But if I do this, let me print the events too. Print events too. We'll be having the data frame and just keep an eye on the is purchase. That will be giving us true, false, true, false. But later on, we need the number of purchases, number. All right. So in order to do that, what I'm going to do is another as type integer. Make sense? So rather than having it as a true, false Boolean, I'll be having it as 0, 1, 0, 1, 0. Make sense? Now it is easy for me to group by. All right. So initially we have done this. There is another way, we'll see that, but that is a little bit trickier way. We are just going step by step. All right. In the users table, users feature table, what do we want to have? We have to do the events to dot group by. Group by what? The user ID. All right. And then we'll be having aggregate. All right. Aggregate. We need to have 3 columns. One is number of events, which is basically on what? The type of event and size on that. Or count. Both will work. The second one is n purchases, number of purchases, which is on the is purchase column, and take the sum of all the is purchases according to the grouped by user idea in the semicolon. Not a semicolon, what is in the string literals. Total revenue is equal to, how do I get the revenue? The amount, remember, we have the amount, and sum. All right. And if I try to print the user features, the print is already there. Let's see. We'll come to reset index later. All right. But let's try to see what is the issues.
It's a semicolon on line number 2.
Line number 2, where? Oh. All right. That is an issue, but this is an issue right here also. Total revenue. Should I be having this in? I don't think so. Okay, I don't think so that I need this. Number of events, okay. Still not really good at the syntax, huh? Is purchased
Isn't it
is
events to dot group by?
Events too. You have to do events too table.
Events to
User
line,
feature,
line
oh,
colon events.
Yeah. Now
all right, that was the issue. So we have group by, now it will be working perfectly fine. All right, user ID 101, 6 events, number of purchases 2, and this is the total revenue. Cool. Because the events table didn't have the is purchase function. No? That's what it was telling me. All right. What is the purpose of reset index? That is one of the things that we have to figure out. And another thing that we have to talk about is, which is a fan gotcha, which will be asked in the interviews, is when we are doing the aggregation, then one group by aggregate with the name aggregation is idiomatic and avoids multiple passes over the data. How? What is it trying to say is, then we are doing the group by and we are using the aggregate for the multiple columns. We are going over the table only once. How does that happen? What they want to say is that you made an is purchase, you have the amount. For getting the aggregate of the amount, or for taking the number of events. When you took the number of events, you went over, you grouped by, right? Imagine it like this, right? 101, 101. So you took the event over here, you took the event over here. You made the group by object only once, and you took the number of events. But for the second line, that is when you did this, we didn't take a pass. We didn't take a pass. This is what it means, that it is idiomatic and avoids multiple passes. How? How does this happen? One, it avoids the multiple passes. How does that happen?
Because it's a series, by series, vector.
No. That is vector, but still, if it is a vector, it will be vectorized operations, right? We'll have to go over all the data, right? This is what happens in GroupBy. A little bit of under the hood details, and they will be asking it that how does it avoid the multiple passes? Or they'll not be saying it avoids the multiple passes. They'll be saying that, okay, what is the time complexity, how much time it will be taking, or how can you make it fast? All right. So the thing with the GroupBy object is that under the hood, it makes a kind of a dictionary. If it is user ID, then 101, 102, 103, 104. Makes sense? And then to that dictionary, we have different things. For example, it stores in the first group by only, it groups by all the columns like this. For example, events. You want to take the sum of the event, you want to take the number of the events. You can take it from this portion right here. For example, the event is equal to view, purchase for 101. Okay. Similarly, amount. Similarly, is purchase. It does the things like this. Now, the advantage is that you took the number of events. You went to 101. You took the number of events, which is basically the size of this list of 1. Then you went to the amount. You already have the amounts. So you are just taking the sum of the amounts. It contains, in fact, it contains the sum, the count, everything over here. You just go over here for the amount, you take the sum. That's why it doesn't go over the complete table again. It just goes to this group by object dictionary over here, under the hood, and it gets the things in O1 from there. So only one pass is done for making this group by object. And if we print the type over here, if we print the type of the events to dot group by, user ID, then you will see that this object is getting made. All right.
Wrong spelling.
Where? User. All right. So we see that it makes a Pandas core object, which is group by under the hood. Make sense? So we go to this. If you have to make a mental model, then to go to this group by object, we get the event size, we get the amount sum, we get the is purchase count also, whatever count or sum. So only one pass of this table is done. Make sense? Yes, Lohit, go ahead. What's your question?
So just curious, like the amount is per event, like views, total amount, purchase, total amount, like that. Like I'm just curious, like so you mentioned like it creates a view for a user ID, like it captures the events.
Not a view, but a kind of a dictionary under the hood. Makes sense? Or a hash map.
Okay. Yeah. So yeah, I mean, like just curious, like what happens like in amount. So let's say there are like 5 view events, so it's doing a sum for that under the hood.
No. It's firstly one by group 101. Na?
Yeah.
It is for 101. For the amount. If the amount over here is 20, over here is 40. So I will be having this. All right. Amount is equal to 20. Amount is equal to 40. Sum.
Correct.
60. Count equal to 2.
Okay.
This kind of thing. All right. Yes, Akash, go ahead.
So how is this aggregation different from the aggregation that is done in SQL? Like,
It's fine. It is pretty similar to it's. In fact, in the SQL also, it uses the same concept. All right. It's not the aggregation part. It is same, consistent in Pandas as well as SQL. But Pandas has an advantage.
Vectorization.
The data is in memory. In SQL, the data is not in memory. Vectorized. Makes sense? So don't lose of the initial premise. All right. It's not only that we are making the Pandas data frames just for the aggregation, right? And a lot of things we will be having consistent in SQL and Pandas. But doesn't this aggregation in SQL also is done like this? All right. The SQL engine also works like this. All right. So there also it is idiomatic. All right. Yes, Samiksha? That's a great question.
What if one of the amounts is null? So how is sum calculated that time?
So we cannot fix something at this level. All right. If the nulls are there, then they have to be checked with the function is NA. For each column, when we are exploring the data, before doing any operations on the Pandas data frame, then we have to check all the columns for is NA. All right. So if we are doing is NA among the columns, then we will be coming to know that there is a null which have to be plugged in. For example, if the amount is null at any of the places, all right. So before doing that filtering of that, if it is a purchase, make the amount is equal to 0. We can replace the amount with a valid number. For example, I can replace it with the mean. I can replace it with the median. If it is that the column or the series is salary, then median makes more sense. If it is amount, then mean makes more sense. Depends upon the use case. But we'll not be doing it at this level. We'll be already would have done it. All right. That's again a very. In fact, when we will be building the models, we will be checking for the is NA. All right. In this lab also, in the further, if there is NA, then we will be replacing it with something. All right. Anybody else? Any other question? All right. Let's go ahead. And this is the way that we can do the GroupBy.
In real time, right? With the modern systems, are we still using like Pandas or Spark? Just want to make like
the industry is moving more towards polars right now, but Pandas is still a great tool. For the classical machine learning, Pandas is still a great tool. All right.
So when you say polars, right? So is that also for distributed computing or just it's like a same like a Pandas, not for distributed?
It is distributed, but it is not as slow as Spark.
Okay.
All right. I don't know under the hood how the polars work, but that details we can get later. The concepts that will be there from data extraction, encoding, transform that we are doing right now will be holding good over there also. Make sense?
So it will be syntactically same or is it like different?
The syntax will be different. The mental model will be same. Make sense?
Okay.
That check these things. If you are doing these things, check these things. Make sense? If you are doing GroupBy, then don't assume that it is going over the data frame again and again. All right?
Okay.
So join and merges. Again, it is pretty consistent, same as that of SQL. But firstly, we will be looking at join and merges, which we'll have to do in our when we are building the models, when we have different, for example, users table and another events table, we have to merge the things, right? So what kind of joins that you have studied till now? What are the different joins that you have come across?
Left, inner,
Cross
outer.
join, inner join, left, outer joins.
Left join, inner join,
Cross join.
cross join, which is basically inner join only, right join. If we have the data table on the left, data table on the right, inner will give me what part?
The middle one, common.
Intersection.
The intersection. Make sense? So what I want to say, Pooja, is we are doing one tool, that is Pandas. All right. But the concepts like data leakage, which happens in the Pandas, or the concept of row explosion that we will be learning, or the concept that we already learned like this, those concepts will still hold good in the other tools also. So you focus on developing the principles rather than going to each and every tactics. Huh?
Yeah.
All right. So inner join will give me this. If I'm doing the left join, then what?
Left side excluding inner.
No. Complete. This plus this, huh? Left. Complete left, huh? All the left. Make sense? If we are doing the right join, all right, except
Right.
everything on the right. Make sense? This is the mental model for the right join. Cool. So now we'll see the different joins that we can do. In Pandas, how can we do the join, or what is the syntax? Firstly, we have to mention on which column or on which series we have to do. For example, for user ID, we will be making a join. Why? Because the user table also has the user IDs, and the events column also has user IDs. All right. Another thing, another thing that we have to mention is how. All right. How? This is the syntax. You have to mention left or right or inner join. Make sense? So let's do a normal join for now. For example, if we have two tables, for this exercise, let's take two different tables. One is the users table, which has 101, 102, 103, 104, 101, 103, 104 again. And this is user ID. And this is phone number. All right. So phone number is 007, 008, 009, 010, 110, 11, 12, 13. So one user can have multiple phones, right? And another table that we have is the orders table. All right. And in that, we have UID 101, 102, 103, 101 again. Because one user ID can make multiple orders, 102, all right, 103, and 104. All right. This is a UID. And before that, I need to have order IDs 1, 2, 3, 4, 5, 6, 7. And here we have amount of the order. If we have 2, 4, 2, 1, 3, 4, 5. All right. Now we have to think if we are joining these two tables. All right. Whether it is a left join, whether it is a right join, doesn't matter. Whether it is a left join, whether it is an inner join. All right. And another thing that we have to take care is the NAs, the nulls that Samiksha was worried about. For example, it may be very well possible that I do not have 104 right here. Make sense? For now, we'll be having 104. For the later, we'll be saying that, okay, it may be possible that we do not have the phone number of 104. All right. Now, let's do a simple join first. In the exercise, we have the users table, the initial table that we built, the users table, and users features table that we have already made. So initial table is the users table that we made, and this is the user features table. If we want to join them, where do you think we'll be joining them? On which column?
User ID.
User ID. All right. For one user ID, we'll be joining them. All right. So if I have to merge the users with the users table, so users dot merge, which is basically like in SQL we have join with which table? Users feature table. Then on what? User ID. And how? Left. Left join. Makes sense? So if we are doing this, and then we'll come to this. Now, if I print the users table, it would have joined the two tables, and let's see what are the different columns that we'll be having. Users is not defined. Users can only merge series or data. String was okay. My bad. It is not a string. It is a data frame. All right. So we'll be having data frame like this. All right. It will be having the user ID from the users table, country, sign up timestamp, number of events, number of purchases, and total revenue. All right. This is the way that we will be merging them. And then the next step is that they say that we have to fill NA. Because imagine if we don't have 104 and we are doing a left join of this with this. Or if we have 104 over here, but we don't have 104 over here, then what will happen? What will happen in that scenario? Then,
Yeah.
yeah, go ahead.
Order columns
One of
would
four
be
will-
0.
For now, let me take only uniques. Okay, only uniques over there. And imagine only the uniques over here also for now. All right, then we'll take the repeats. So 101, 007, and UID 101 from this table, and amount is equal to 2. Here, 102, 008. Remember, we don't have the repeats. Only the first 3 rows are there. Okay, so 102, 4. And 103, 00, 9. And amount will be equal to 2, 103. 104, 10. Here will be nothing. Make sense? Because in the order table, we do not have the entry of 104. And in the left join, I need to have everything on the left. Everything on the left. So all these rows will be there on the left. All these entries will be there. But I don't have the data for that. So if I don't have the data for that, then I'll have to fill NA. That these columns have to be filled. All right. Will not available. This I can fill. This is UID only. This I can fill. 104. But the amount has to be filled with something. Make sense? If there is not nothing, I can fill it with 0. That's exactly what we will be doing. All right. Now, just a moment. Users.merge. With user features table on user ID. How left? We print it. This should be the thing. Why is it failing though? All right. What we are doing is we are going over each and every column. If the column value is not available, I'm filling that. The not available are filled with zeros. All right. This is fine, but why is it? Oh, because I don't have the solution rating. Did I miss this? Oh, I missed this. Okay, let me do this. Okay, this is the group by. Okay, this one is failing because I have not completed this exercise. Okay, if I complete this, still it is failing. Yeah, okay, I got it. It expects the earlier one to pass as well. This one is fine. This one is fine now. Or it might be expecting. It might be expecting 0.7 point, the earlier one on reset. Is there an issue? This one is fine. This one is fine as well. Fine as well. Fine as well. There may be some issue with the lab itself.
Error.
No?
Error and purchase is itself.
Yeah, so it is. So it is. Might be. I might have named it incorrectly then. And purchases.
Yeah. Oh, and
It's because of this. Okay. All right. So this is fine now. Okay. So this is fine that, okay, we have to just do this only. All right. I had named it incorrectly over here. That's why it was failing, because this lab works like this, that the earlier task should be having the similar kind of naming, but we are doing it right here. Okay. So one of the things but I left was over here. Okay. I'll come to that. All right. So this is the way that we will be doing join and merge. This is the transform that we will be learning. For example, when we grouped by, this is one of the tasks that I missed. In the group by, two things I missed actually. One is the reset index in the group by, and another one is the transform. So what does the group by do? For example, if we have this table, which is events table, and I have the indices under the hood for the data frame like this. Now, once we have grouped them by, then I will be having 101, I will be having 102, and I will be having 103. All right, and there will be some columns over here. What will be the indices of this? The indices will be, it may be possible, the index over here is 3, because in the group by object, we have taken the second one. All right, the group by object has chosen to group by and take this user ID, which is at index 3, 102 from index 2, and 103 from index 2. The indexing of the group by object or the group by table has gone for a 6. And that's where the reset index comes into the picture. That do not use the index of the parent table that you have. Reset the index so that this becomes 0, 1, 2. Does it make sense? That's why we are using the reset index.
Sorry, sir, I lost you. Can you please repeat this bit?
Okay. So when we had grouped by, if we have grouped by the events table by the user ID, right? So firstly, the group by has to happen for the user ID, 101, 102, 103, right? All right. We have to be a little bit fast. So it may be possible that the group by object is choosing the very first or the third one also. All right. Because we have not mentioned anything that take the first one or take the last one. So by default, it can take 0 also, it can take 3 also. What if it has taken 3? Then I'll be having an index 3 over here, right? I'll be having an index 2, index 4 over here. All right. Index 2 over here. All right. So the indexing has gone for a 6 when we have grouped them by. So in order to reset the index so that we have 0, 1, 2 over here in the group by data frame that we are resetting the index. All right. All right. Fast. Yes, Lohit.
So it created a view, and by doing this, like we are creating a copy of.
No, it creates a different data frame. It doesn't create a view. All right. It creates a different data frame because it is creating a group by object. That's a separate object than the data frame now. All right.
Yeah. Okay.
All right. So this is, and what does transform do? So for example, if I have grouped them by, but I have done for 101, 102, 103. But it may be a possibility that in the same events table, I need what are the number of events for this. For each entry, for each row, I want to list what is the number of total events that 101 had. For example, 2 events. Then in number of events, I want to have 2 over here also. I want to have 2 over here also. All right. Because the group by will be condensing it to the number of users only. These 5 rows will be condensed to, these 5 rows will be condensed to 3 rows, right? But if our use case is that in the original table or on the table, on the complete rows, I want to have this number of events. In that scenario, what we can do is a transform. In that scenario, we'll be having that events 2, which we have made a copy, users event count will be equal to events 2. Group them by the user ID. All right. And then on user event count. So event. Rather than just taking the size, I'll take a transform on the size. So that for each row, we can have an entry. All right. If we do that, if I print the events 2 now, then I'll be having the number of events for each and every user, but for each row, all the 30 rows will be there. Make sense? And for each user, 104, the total number of events was 8. That's what we are storing with. That's the use of the transform. All right. Because in our model, this may be a use case that I don't want just the counts. I want to have a line entry against each user ID.
So transform is just like a analytical function or like a window function, we say in Pandas. It's
We'll
like
talk.
equivalent.
It's not a window function. It basically takes from the GroupBy object the values and it just fills over there for each and every user ID. All right.
Yeah. Okay.
All right. It's not a window function. Window function are the functions which does this. All right. So transform is just from the GroupBy itself. It is the further continuation of the GroupBy. Make sense, Pooja? All right. Now let's come to the GroupBy and merge again. What if I have 101 and 11 over here, 102 and 12 over here? Or for our lab, what we are doing is very important concept. Give me full concentration. Is join and merges. Okay. Diagnose and fix a many-to-many join explosions. All right. We have one of the data frames, which is K, column K and column L. 1, 1, 2, and N, A, B, C. And another data frame that is right. This is called left. This is called right. In that, we have a K column, which is 1, 1, 2. And R as X, Y, Z, L, X, Y, Z. Now they say that if we have to merge left with right on K, how the inner join? We are making an inner join between the left and the right table. We are making an inner join. What will be the output? What will be the output that you will be having?
Left. So all like 1A, 1X, 1B. No. 1A, 1X.
1A. So from the left table, I will be having K. Let's call it LK, left K, left L, and right K, and right L. All right. So 1A will be having what entry?
1X.
Okay, 1X. Next.
And then 1A, 1Y.
1A, 1Y. Okay.
And then 1B, 1X, 1B, 1Y.
1B, 1X, 1B, 1Y. Perfect. Then?
And then 2C, 2,
2C, 2, 3. All right. So when we are joining them, rather than having 3 rows, now we have 5 rows. Makes sense? Anybody wants to differ with this? This is exactly what will happen. And how does it happen is this way. It's an M cross N solution. M cross N lookup. Make sense? So firstly, we take 1A. We check where, remember what we are joining on? K. Is it 1? Yes. Take this entry. 1A, 1, X. Then it goes right here. Are you 1? Yes. So 1A, 1Y. All right. Then it goes right here. Are you 1? Nope. Then we go to the next row. 1B. Are you 1? Yes, you are 1. So 1B, 1X, 1B, 1Y. This phenomena from where you have 3 rows, but when you did the inner join, or you are doing the left join, or you are doing the right join, because of many entries, I will be having something called row explosion. From 3, I will be having multiple rows. This phenomena is called row explosion. Now, your use case might be that you just want to have one entry. That, for example, in the orders table and the user table, does it matter whether the user has 2 phone numbers? Belonging to one order ID, you need only either the primary phone number or the secondary. Because if you start having all the possibilities, then this will go M cross N. There will be row explosion. There will be memory explosion in your data. And your use case must be that, oh, I need only one phone number belonging to one order, right? And unintentionally, you will just join them and you'll just sit idle. But somehow you'll feel, oh, my data is not working when there is a memory limit exceed or something like that. In order to save the row explosion, what is the remedy or what is the medicine that we'll do?
We try to
Group.
aggregate.
Huh?
We try to aggregate somehow.
Aggregate, and in the aggregation, you will be having all the phone numbers. Is there any other thing that you can do? Why to aggregate? Why to make another table of phone numbers on?
Can we drop multiple values?
Can we drop duplicates? Can we drop the duplicates at the time of the runtime? Can we drop the duplicates? Is what we will be doing exactly. Make sense? So when we are doing the write, then we can drop the duplicates over here on the right, so that we do not have the row explosion. So write dot drop duplicates. Duplicates of what? K. And then you have to decide which one you want to keep. Either you want to keep the primary phone number or the first index of the K or the last index of the K. For that, you can mention keep first. Make sense? This is what you can do if you want to avoid the row explosion. I'm making some mistakes somewhere. Drop duplicates, K, keep first. This is fine. Where else? Okay, I have not. What was the issue?
Casing of first, I guess.
Capital F.
Oh, capital F versus small. Okay, that was the issue. So we can drop duplicates from the right so that we do not have the row explosion. Make sense? Now let's go to the next. Anybody, any questions till now? How many? Okay, 2 tasks left. Okay. One is the leakage safe time features. This is the place where we'll be using a lot of time. Okay. So leakage. What is leakage? And why does it matter in machine learning? And one of the one-liners that we can use for Pandas is that Pandas is a great tool, but being a great tool, it makes it easier for data leakage to happen. All right, that is one of the disadvantages. And other tools also, if we are not using them correctly, they will lead to data leakage. What is data leakage? Anybody?
Data gets spilled to the disk, and then it takes more time to network cost increases.
No. Anybody else?
Yeah, basically that when we are training a model, if that data is spilled over to the test data or the signal from the train is in the test data set, then it's called data leakage.
Perfect. So now when we'll be having the complete data, right? We'll be having the data for ourselves to work with the to make the training model, to train the model, and to test the model. All right. So if there is spillage of the training data to the test data, then that phenomena is called data leakage. Further, data leakage is of two types. That is the data from the features. Feature data leakage. That is from these features, age, salary. We made the bifurcation like this. This is the training data, and this is the test data. 70-30, for example. And from this, some rows are going into this. All right. Another one is a leakage which is called target leakage. All right. In which there is some data which is directly giving you a signal whether I should be classifying it as a 0 or 1. For example, if we consider churn, customer churn, the target is churn, whether the customer is churning. And we have one column that is refund after churn. We are selling Airtel plans, age, salary, plan. And we are trying to guess, according to the plan, age, salary, the last payment, we are trying to get whether the customer will churn or not. And if we have a column which is refund after churn, the model is directly going to guess that whether the customer churned or not. It doesn't need the other data. It can just look at this column only. That is a target leakage. That directly the target, we are already giving the target labels, or we are giving a column which is giving a direct signal whether the customer will churn or not. That is the target leakage. Feature leakage is that some rows from this data is going to leak into the from the training data are going to leak into the test data. That is a kind of data leakage. But typically how Pandas make it very, very simple is the way that Samisha was talking about, was thinking. Imagine if we have not available features, for example, age is 32, age is 31, 30, and there is nothing over here. 28, 25, 26, 32, and 31. We need the bifurcation of the test data and the training data. All right. Imagine if we don't have anything over. Then with Pandas, you thought that I'll be filling the NAs. And what should be the NA over here? What should it be filled with for the age? You decided that I'll be filling it with mean. Makes sense? How do we take the mean? On this NumPy array or on this feature, you take the mean. You have the Pandas series, you take the mean on that and fill the NAs with the mean. What has just happened? Data leakage. How? How has the data leakage happened? Because I should have used, for filling the NAs for the training, I should have used only this data. But now I am completely using the test data also to calculate the mean. And I'm filling the NAs accordingly. So Pandas makes it very, very easy for the data leakage to happen. So in the models, then when we will be developing, firstly, we will be making a split of the training data and the test data. Then we will be filling NAs. A lot of times you'll see that on Kaggle, people have already taken the mean and filled the NAs with the complete mean. That is data leakage. The interviewer will ask you this question: should I be taking the mean initially or should I be doing it after training and test split? Either if your question is doesn't matter, or if your question is initially, then that is a telltale sign that you are not doing the correct thing. Make sense? So now, if the data leakage has happened, this is the type of the data leakages. Now we'll see that not only with this mean median that Pandas makes it easy for the data leakage to happen. It can work. It can make the data leakage happen in this manner only in a simple task like this. If I want to take the cumulative purchase of the count, strictly before the current row, how many purchases have happened? For example, initially we sorted the events. All right, on the timestamp, user ID. First sorting is based upon the user ID. So I'll be having 101 first, 102 first, 102 later, 103, 104, so on and so forth. And second sorting is based upon the event timestamp. All right. So if I print events 3, on which initially we have taken the copy on the events, okay? If we print events 3, then we'll be having 101 and the very first timestamp of 101. Then 101, the next timestamp. Then later on 102, the very first timestamp of 102. This is what we have done with the sorting. And we have added an is purchase column into the events tree. Whether the purchase has happened or not, we have already talked about it. Now what we want to do is we want to have the cumulative purchase count strictly before the current row. So if I want to take the cumulative sum, this is the window function. How do we do it? That from the current row, if we have the events 3, group by what? The user ID and event, number of purchases. So is purchase, and we have grouped it by user ID, is purchase, and cumulative sum. Take the cumulative sum. So let's just print it. Print the events. User ID. User ID. Not this. Okay. So print the events 3 now. If we print it, then I will be having purchases cumulative in this column. So 0 over here, 0 over here. We made a purchase on this day, but still we will be having this. Remember, the cumulative purchase count should be having what? Strictly before the current row. So we have the cumulative purchases, but it is including that row as well. So we have a leakage. If we have the current row, I have the leakage of the current row itself in the current row cumulative sum. I want strictly before it. So how do we do it? For example, if I take the cumulative sum for this row, the previous row element will be flowing over here. Make sense? That is the kind of situation that we can have. So in order to fix that, what should I do? I should be making it shift by 1. And how do we make shift by 1? Is purchases before is events, purchases come, cumulative, shift by 1. All right, before going over there, I did the reset index and the sort also. Because the original tables indices, it would have sorted. For example, if a 101 was right here and 102 and 101 right here, 0, 1, 2. When we sorted them, 101, 0, 2, 101, and 1, 102 would have come. That's why we have to reset the index. Make sense? So in the sort values also, we reset the index. Over here.
But we are not using index anywhere, right? So even
It's
if we reset or not, doesn't make any sense.
Yeah, doesn't, not required, not essentially. All right, but a good practice. All right. So shift by 1. If I shift it by 1, and then we are going to fill NA. Not available ones with 0. Let's do it without fill NA. Let's do it without fill NA and try to print the events 3. All right. What we'll see over here is that we have shifted. So before this row, I had 0 events only. Before this row, I had 1 event. So I have 1. All right. Before this row, I should have had 2 now. So what is the issue? Why is not cumulative sum working? Oh, no. It's cumulative, right? So cumulative 1 only. So 1 only. Cumulative is already containing the total number. Make sense? So, and we had a 0.7 only, right? 0.7 only over here. So in the events only, I have only 1 purchase, in fact. I have only 1 purchase. All right. 1 purchase only. All right. So 1 is absolutely correct over here. All right. But the earlier issue that including this row, we had the cumulative sum because the event has happened. We had 1 over here. Now we have 0 over here. But the problem that has happened that for the very first row, we have not a number. Why? Because if I have shifted by 1, for the very first row, I will not be having any entry. That's why we'll be using fill NA with 0. So that we are able to fill the very first row with 0. Make sense? Now if we submit it, it works perfectly fine. These are the kind of things, or these are the kind of challenges that we will be facing, and this is the way that we will be fixing them. CumSum or rank, this is a window function. In window function, what do we do? When we have the data like this, for example, in cumulative sum, 101, 102, 103, 101, 104. All right. Let's take it in the sorted manner only. 102, 103, 104, 104 again. In window function, what happens is, whether it is SQL, whether it is Pandas, the window function does this. Makes a window right here, and in the CumSum, it writes 0. All right. If the purchase is 0 over here. If the purchase is 1 over here, next window, it will take the cumulative sum, earlier 0 plus 1, like a running sum. It will be having 1. Then for the next window, it will be having 0, so it will be 1 only. No purchase, cumulative sum, 1 only. For the next window, it will be earlier plus 0, 1. Over here, this is 0, this will be 1. This is the way the window functions work in SQL and Pandas. CumSum is one of the Windows functions. Rank is another window function in which we have to do the ranking. For example, 101 scored 78 marks. 102 also scored 78 marks. All right, 103 scored 79 marks. 104 scored 80 marks. Both will be having rank 1. Na? So if we are doing, then I will be having window 1. Over here, same. So rank 1 only. All right, then we have over here, either with the rank, we can have 2 over here, or we can have 3 over here. Figure out and let me know what is the difference between rank. If I want to have 2 over here, or if I want to have 3 over here, what should be the way that I can make the rank? All right, but both are window functions. All right, this is the way that the window functions work. All right, let's go to the, anybody, any questions till now? Let's go to the next step. That is, we are going to compare the last step is vectorized versus non-vectorized function. That is, apply is a non-vectorized function, and vectorization we have already seen. All right. For example, if we want to filter, what are the rows with country is equal to India? All right. If we have to do it with non-vectorization, for example, in the vectorize, how will I do vectorize? All I need to do is the Boolean mask. All right. We are going to make a larger data frame. So pandas dot concatenate the users data frame into 25,000. All right. So we are making a very big data frame so that we can see the effect of vectorization. All right. All right. So let me just see if we are doing it correctly. Print u.head. All right, perfect. Now what we are going to do is we are taking the initial timestamp T1, and then we'll be recording the time of the apply function. How much is the time taken by the apply function? Over here, we'll be making an apply function. We have the country. All right, dot apply on it. For the filtering, apply on it a lambda function, which is x, if x is equal to India. This is one of the ways that we can filter it. Another way that we can filter is with the vectorize operation, that country is equal to India. Make sense? This is the vectorize operation, and this is the normal way that we are doing the lambda function or the apply function. Let's see the times that how much is the time taken for both? The time taken for one of them is 0.012, another one is 0.005. We have a speed of 3x almost than the apply function. Again, we solidify our fact that we have to use the vectorized operations. We cannot use for loops. We cannot use the apply functions. All right? We have to always use the vectorized operations. If come what may, you have to do something like a for loop. Rather than doing that, we will be doing the list comprehension. That is the lambda functions we can use. They are faster than the for loops. But nothing beats the vectorized operations. All right. We are done with the class. Anybody who has questions can stay. Anybody who doesn't have questions can leave.
Oh, yeah, I'm like trying to understand target leakage example, the data leakage. So
Mhm.
can you explain that? Like, I mean, like I'm able to understand the feature data leakage.
Let me tell you. All right. So going into a little bit of model building, when you have the training data and when you have the test data, make sense? So if you want to train your model, what all things you will be giving if you want to see the churn? Plan, last payment, amount of last payment, pending balance, salary, age. And you have the label data, right? Whether the customer churned or not churned. Let's say you have 100 rows for that. Now you have to divide your data into the training data and the test data, right? Make sense, Lloyd? Now you can decide. For example, you can do the permutation, basically mixing all these rows. And then you can say that I will be using 70% of the data for the training data and 30% of the data for the test data. All right. If some of your test data already leaks into the training data, make sense? Or before going over there, tell me out of these features, if you're building a model, if you're training a model, which all columns you will be giving to your model? Which all columns you will be giving?
I mean, except churn, like I'll be giving every.
Except churn, you will be giving all, right?
Yeah.
Except the target, you will be giving all. Why? Because you want to see what is the predicted target by your model. All right. So let's call it Y predicted. And this is target, Y and Y predicted. This is Y predicted and this is Y. Make sense? Now, in order to train your model, you will be reducing the difference between them, the deviation between them. Don't think it's numerical. It may be categorical. You will be calculating something called loss function. Loss function is that how much away you are from your actual. This is predicted. This is actual. Now, what happened? Suhas forgot to drop this column and he gave to the training data this churn itself, the target itself. And Suhas comes and he says, hey, I got 100% accuracy. I built a model which gives me 100% accuracy. But when I go to the real world, my model is not going to predict anything. It gives me 0 accuracy. Ajay is his colleague and he says what? That you have given the target itself to the model. He will be predicting everything every time correctly in your training. Now, this phenomena is called overfitting. When the model already starts knowing the answers, you have given him the answer on. It's basically Lohit was sitting in 10th class and he has already got the solutions in front of him. He became a doctor. When he went to the real world, he's killing people. Make sense? That kind of scenario. That is target leakage. You have leaked the target only. Make sense? Now everything is working fine for him, but in the real world, it is not working. The second thing is the data leakage. You do not want to leak the training data to the test data, right? You want to keep them different. One is for training your model, that on 80% of the data, I am training my model, and with that, I'm going to fine tune and I'm going to make this Y predicted very, very nice. Very closer to the actual Y in my training data. But what happened that you are going to test that trained model on some data. Niharika came and she said, just give him some of the test data. So tomorrow when it runs on the test data, it really performs really well. Good. Fine. It will work really good. Will it work really good in the real world? It's just like a student whom you have given some hints so that he was performing really good. But in the exams, he will not. This is the feature leakage, that you provided some of the data from these features into this data over here train. That is data leakage. And typical scenarios, typical issue that it will lead to is overfitting. Make sense? And overfitting's telltale sign is what? That your data works really, your model works really good in training, and it works really bad on the real world. But that is not the only case that overfitting can happen. Overfitting can happen when the model has looked at even the small noises in your data. It absorbs the small noises in your data as well. Even every signal is caught. You might think right now that it is a great thing. It doesn't. Because it may be possible that in your data, there are some outliers. For example, if I give you this kind of data, all right? And tomorrow, if some test data comes over here, one of the student has fit the model like this. But if in your data, some noises are there, if you catch each and every signal, then Lohit says, no, I'll fit my model like this. Good luck finding what will be the probable prediction of this data, test data. This is also overfitting. Overfit. A generalized model is much better than the overfit model. Make sense? And the data leakage can also lead to the overfitting because it knows the answer. Oh, answer over here is this. Make sense? But in the real world, it doesn't perform good. That is the issues with the data leakage. We should not let it happen. Pandas makes it very easy for data leakage to happen. Cool? All right. Anybody else? Any other question? Bye, guys. Happen.